All right, let's get started. So, hello everyone, and welcome to the Cadence Best Practices webinar. We are delighted to have you in the first webinar of a fresh series of topical webinars for Cadence. This will be end-to-end a 50 to 55 minutes webinar where we'll cover multiple topics that we'll talk about in our agenda. Today, we have a diverse audience of 40 plus people joining us from multiple different organizations. The audience includes a mix of contributors and consumers of Cadence, new as well as experienced users of Cadence, as well as people from US, Europe, Asia, Australia, and more. As we run the sessions, we have the Q&A option for all of you, where you can ask questions on the go. So if you see the next slide, you'll be getting the answers from the Cadence experts on the call. And in the end, Ender will also be taking up those questions. So you can also upvote the questions that others are asking on the Q&A. Now, let me introduce you to the host and the presenter for today. So I'm Vinay. I'm a product manager for Cadence and an open source enthusiast. You must be seeing periodic announcements from me on Slack Workspace. I primarily take care of Cadence PMC and the community that we have. We also have the presenter for today, Ender. I would like to invite Ender now to introduce himself and also tell us what's the agenda for today.
Hi, everyone. We probably met with some of you through different conferences or at your company. I'm at the Cadence team for the last 3.5 years, getting close to 4 years. Very excited to be with you today and excited to hear more questions at the end of the presentation too. Back to Vinay. Actually, I can take it over from here because my slides are going to be from here. So today, before the webinar, Vinay actually ran a survey, talked to some of you individually, tried to get some topics that you would be interested in. So some of these topics are going to be, for example, scalable task lists. I will talk about it, but there's going to be another webinar in much more detail in the future. And some of those I will be able to go through today as they are not that big. So this has been the first webinar we decided to start with users' voice to see what you are wondering the most. So this is going to be, the level of this webinar is going to be more like, Cadence, you probably have a little bit of experience, so like beginner to medium experience. Even if you are advanced, I think some of these topics are going to be interesting to you. And then we will share our high-level roadmap. And at the end of the presentation, we will share some community updates and accept your questions. So let's get started. So before getting into scalable task lists, I prepared this slide about 2 years ago, and I found it very useful for users to understand. Whenever you're thinking about Cadence or a similar technology, if you think about this slide, I think it will make a lot of things a lot easier to understand. So let's go through the numbers. So we have, on the user side, we have something called starter and a worker. They could be in the same service, they could be in a separate service. What starter does is it starts the workflows and sends its parameters. And what happens is that whenever you say start, all what Cadence does is it records them in a service called history. So you can think our history as our ledger service. Everything you do in your workflow will be saved there. And then as soon as we record something, we will schedule something, schedule the next thing to do. And then you will see that the worker will pull tasks from matching. So matching will match your request to based on the task list you are pulling from to the tasks, and then it will give you a task. You will execute that task, and then you will respond. And then history will say, "Oh, I have the response. Let me record it," and it will schedule the next thing. The whole logic of Cadence works like this. If you think about it, I think it will make a lot of things easier in the future. So since we are talking about scalable task lists, I will go into a little bit more detail. So now I added something looking like a rack, and then I added some parameters to start response, and I made the task list bold. There is a reason for it because these matter. So on the history side, our sharding logic depends on workflow ID. And workflow ID is something user sets in the beginning of their workflow start. So we will talk about a lot of things regarding workflow ID. So I want you to remember this slide that workflow ID will decide where your workflow is going to be recorded in history. And then similarly in matching, everything is sharded based on your task list. When you are polling tasks from a task list, it will go to a specific host owning your task list. So in distributed systems, we know that single shard, single host will not be able to scale infinite amount of times. That's why we have scalable task lists. So what do? We just split the task list into multiple partitions. You basically say how many partitions you want to have in a task list. And then in matching, we will have multiple hosts owning the same task list, different partitions. And then when you are polling from that task list, it will now randomly pick one of those hosts, and then you will get one of your tasks. So this is how we are able to scale your tasks and how you can keep growing your use case with Cadence. And one popular question that Vinay told me, how am I going to know if I need to scale my task list? So this is like, I took some screenshots from our Grafana dashboards. We plan to share these templates, even though all the metrics are already available today. Feel free to ask me about specific queries I can share in the Cadence workspace. So this is like how we see we can see the distribution of task lists among different matching hosts. Then we can see the RPS for specific task lists. So this is the host traffic, and this is the task list traffic. So the rule of thumb is, I think, as a recommendation, whenever it is like more than 100 requests per second, it might be a good idea to start considering partitioning. But if your matching host is if your matching host is doing well, if there is no backlog accumulation, might be okay. It is. You will hear me saying this a lot. A lot of the things will depend on your workflow size, the data size, and also the frequency and different type of patterns. So there are some recommendations, but eventually your own pattern will dictate when you are going to take a specific action. So if I summarize what scalable task lists are for, they are useful at high scale. They're distributed to different matching hosts. And signs to watch is that if you start seeing high schedule to start latencies, if you start seeing hot matching hosts, even though we have those metrics, you can also look at your container metrics. They will also be able to show. If you see high async match, so sync match is more like an in-memory match. That means that we have a healthy polar to matching resources ratio. When those things are not in healthy, more of the matches are going to be async, meaning we need to go back to Cassandra, read those tasks, and then dispatch to the user. And then the other one, as I said, there is a recommendation. If you have high task list RPS count, you might consider splitting. And then why not just have too many partitions? Why can't I start with thousands? And if my use case is growing, I might as well be fine in the future. So there are downsides having task lists too. So for example, you want to make sure when you are scaling your task list on the matching side, you should also consider scaling your pollers, either by adding more workers or by increasing number of pollers per worker. Otherwise, we do long polling. When your request goes to an empty partition, it will wait there for about 10 seconds. So that means your poller might be waiting on an empty list while other partitions have backlog and have tasks waiting to be picked up. And then there is a task forwarding cost. I'm not going to go into this too much, I think in the other webinar, we will explain this maybe in a little bit more detail. But there are some fallback mechanisms between partitions, and every time you add a partition, there's a cost to it. So you want to add it when it is necessary. You don't want to add like hundreds or thousands of them. So what are our plans regarding task lists? So as we see more and more users, both internally and externally, and we had a lot of really good discussions with customers, I think what makes more sense is that probably users should not be thinking about these things. So what we are doing this year, hopefully by the end of the year, this is going to be ready, that we are planning to increase pollers as long as like we are able to get more tasks. Then similarly, if we see that there is more CPU or memory resources in your container, we plan to keep adding to concurrent execution thread. So that will naturally scale your workers. It will improve your utilization without you doing anything. And similarly, on the matching side, we plan to add more partitions when we realize that it is getting to a point that it is not able to keep up with the pollers. And then the other thing, if you are familiar with the sticky cache, it is also a worker concept. We try to keep workers in the, if you enable this, your workflows are going to be in this cache, and it will improve your workflow execution complexity quite a bit. So we want to, if we realize that there is a lot more room in memory to add more things in this cache, we also want to make this more dynamic. So in short, we want to make all these hard decisions completely seamless. You wouldn't even think about it in the future. Okay, so the next topic that was asked is, what are some Cadence bottleneck issues? How can I debug them? How can I solve them? So the question was a little bit too vague to answer, but I tried my best based on the patterns we see both internally and externally. So let's go through a couple of them. If you have a specific scenario, please let us know through the workspace. So workflow history size is one that comes up frequently. So we talked about, so if you remember that slide that I was showing, single workflow goes to a single shard. So the bigger your workflow is, the pressure on that shard is going to increase. So this is totally okay up to a certain level. We try to limit it 5,000 activities internally. We recommend keeping it less than 1,000. You may be able to increase it. You may be able to keep it a lot lower. So a lot of the things I will say that it is not like it is gonna burn after that point. It is more like based on historical experience, it feels like these are the safe boundaries. Not enough pollers and workers. This is actually happening a lot more frequently than we would like. That users will say, my workflow is stuck, because that's the experience from their side. Their workflow is not progressing. Another symptom, they will see that the schedule to start latency is increasing. So if you remember, we send something to history, and then we schedule something in matching, and then something needs to poll that. So when the task is ready, but it is not getting polled, the schedule to start latency will start increasing. So that will be your symptom. I would say 90% of the time when you see this metric getting higher and higher, that means you need to add either more pollers or more workers. So similarly, there are two parameters in workers. One of them is about pollers, the other one is about concurrency. I can put the exact parameter in the maybe Slack thread. If you realize that you increase them, but your CPU utilization is still low on your workers, that might mean that your activities are taking and you have a concurrency limit. You might need to increase that number too. And as I said, these are planned to be all automatic in the future. Overusing the same workflow ID. Similarly, so if you have diverse amount of workflow IDs, Cadence is going to perform a lot better, because all the workflows are going to go to different shards. then you will be able to scale better. But if you use a single workflow ID for everything, everything will go to a single shard. It doesn't matter how many hosts you have. It doesn't matter how big your database instance is. If everything is going to one shard, you won't be able to scale. So we do have some plans to change this logic, because normally it is not that a great idea to shard things based on a user entry, and user can just use the same ID over and over again. Those are probably going to be either late 2025 or early 2026. Right now, we are recommending people to have some diversity in their workflow IDs in their domains. And then similarly, I think you can use I think the problem is not the workflow ID itself, is to have a lot of updates in a given time from that workflow ID, because all of them are going to the same shard. Otherwise, we have workflows that are open for years. So I want to differentiate those two things. It is the number of updates, it is not the duration. And then, I think the last one is also continue, as Niv is pointing out the same thing. So yeah, I wanted to put this diagram as a reminder. This is why those are bottlenecks. And then in the next couple of slides, we will also discuss about schedule to start latency. I put a couple of slides for these two. So again, I think if you can understand this slide, it will help you a lot better why like how Cadence is working and how you can design your workflows better. So when you start a workflow, we first have a record saying workflow started, and immediately we schedule a decision. Your workflow worker will poll. Whenever it gives an act, we record it as started and then completed, and then it will go on the same way for activities and decisions. So I put this because you can easily see what is scheduled to start latency. If you combine this slide with this slide, I think it makes it a lot easier to understand. And then start to close latency is basically when the either decision or activity starts till it completes. That's the start to close latency. And then the other thing I think it will be relevant in the next slide. I put this when your worker slice, actually it was more about workflow history size. So I wanted to mention why this is a big issue. So why is bigger history sizes are leading to higher replay latencies? It's because when you restart your workflow, and if you are not even if you are using sticky cache, we are losing the whole context about your workflow. Now we need to download the whole history, replay it until the point that the workflow was left off the last time, then we can resume and execute the next decision. So the bigger your history, the longer it is going to take. That's another reason you want to limit your workflow sizes. And also, bigger the workflow size, the bigger the download is going to be from our history service. Okay, so let's talk about a couple more issues. Batch processing, this was another one. This is actually one of our top focus right now. I think hopefully by the end of H1 2025, we want to be able to resolve all of these issues. One of them is, the main reason this is an issue is that purpose is unclear. Maybe it's with an asterisk. Because from Cadence point of view, Cadence doesn't really know when you start million workflows, Cadence doesn't know if you want to make equal amount of progress in all of those workflows versus if you want to queue those and finish all of those workflows within a certain amount of time. So I would say, based on my experience, 99% of the time, it is the second part. You schedule million workflows, you want to finish them in, let's say, 2 hours, 5 hours. The order doesn't matter, start time doesn't matter. That's why we are building job queuing. So the first part is ready. Start and signal queuing is now supported. This is a very recently finished feature We are going to release a blog about this, and then you'll be able to use in your workflows. This will actually save a lot of back pressure from your own Cadence setup. And then the other thing that are gonna come in early 2025 are Cron queues or Cron trigger queues, however you wanna call. If you have like million Crons that are triggering at the same time, we will be able to queue them. This is the same for timers and child workflows. And then the last one, I think in the problems I will mention why we are doing this feature. When you have million workflows and Cadence is trying to make an equal amount of progress in all of them, and when you pull tasks from matching service, eventually you want to, it will go into your sticky cache, but your sticky cache has a limited size. So what will happen is that, let's say your sticky cache is 10,000 workflows, but you have million workflows to run, it will constantly invalidate the workflows that are in the cache. So what we plan to do is only dispatch tasks for the up until your sticky cache capacity. That way you can execute your workflows without losing its context. That will only take n amount of time because that's how many activities you have, and that's actually going to run things a lot faster. We already have evidence for it internally, so we hope to release this soon. And if you have invalidations, you have to do replace every time. That will cause O(n) square complexity. And then also the large history downloads reduces database performance. This is completely unnecessary if we can utilize the cache and if we can avoid the invalidation. So today we already have some solutions. They are not perfect, but they are still usable. So we have jitters. So instead of starting all of them at the same time, you can put some randomization, delay them randomly so that you can distribute them through like over an hour, over a day, depending on your scale. And I mentioned we have 2 queuing functions that are available today that you can use. Then the other thing is basically just split your execution into batches. You can do it by maybe creating one parent workflow and then creating a child workflow in batches. That way you are controlling your concurrency by yourself, but this will improve your performance a lot better. I think this is the last one in this topic, non-determinism. These are one of the common issues. There are a lot more details in the non-determinism page we have in our web page, but there are a couple main reasons that you will get non-determinism. So first, let me explain what this means. So as I mentioned, your worker might get restarted. And if it happens, we need to replay your workflow to get to the point you left off. So if your workflow creates a different state machine every time that is replayed, that's going to cause non-determinism. We cannot determine how your workflow is going to behave each time we are running it. That's going to fail your workflow. So what are the common reasons for it? Number one is using a non-deterministic type. By nature, these types are going to return a different order or a different result every time. So these are like using hash maps, using thread.sleep, thread.now, or reading a file, reading a network input, using randoms, or doing multi-threading. So for some of those things, you can use side effects if you want to read a value from file and then just maintain that output in your workflow history. The next time we replay, we won't need to read that value again. It will be a part of your history. But otherwise, if you're reading it each time, it might lead to a different history. That way you will get non-determinism. The second one, it is more like if your activity is going to return a different result each time you run it and your workflow, this is, I would say, it is more like about your business logic than non-determinism, because once we execute your activity, we are actually not going to re-execute it during replay. But let's say your activity was getting executed, somehow we lost connection with your worker, and while it is still executing, we already dispatched this activity to another worker. And if your activity is not idempotent, let's say you can charge your customer twice. You can do something twice, or you can say, I already executed this, return something as a failure. I wanted to put it here. It is not necessarily a non-determinism, but if you fall into those edge cases, extreme cases, you might actually have issues. You want to make sure that your activities are also idempotent. They don't necessarily need to be, but if you have it, I think it is going to be, it's going to make your workflows a lot safer. The other part is that if you change your workflow signature, activity signature, it is going to cause serialization problems, and then it is going to return as a non-determinism issue, because previously we were able to fit the parameters to your workflow, to your activity. Now it is not fitting anymore. Now you're going to get an error. And then the last one, it's more like writing backward compatible code. We have a solution if you need to write a code that's not going to be backward compatible. You can use versioning. But even with this, we see a lot of failures that like versioning can make the code a little bit messy. So internally, we built a bunch of tools for this. We didn't have a chance to release it to open source yet, but this is hopefully coming in 2025. This reduced and almost, I think, eliminated all the non-determinism related incidents that our users used to have. What we did was when you send a code review, you can run a command once that will integrate with your production environment. Whenever you send a code review, it will trigger an integration test that will download, let's say, 1,000 workflows from production, run it against your code review, and automatically fail your code review if it is not backward compatible. So that way, first you get the feedback immediately. You still have the context. You don't need to wait until your code goes to production. You can make your fix a lot faster. You can have a lot higher confidence in your versioning. This is one of the, I think, very exciting features we released internally, and hopefully it will be in production. It will be in open source soon. And then maybe one last thing I can add here: when you are using versioning, you can track if all the workflows from old versions are done by using our visibility features. That way, you can avoid accumulating versions forever. You can delete the old versions from your code once you realize that there is no longer any open workflow from those old versions. Okay, so those were related to some known bottlenecks, some common issues. Then the other popular request was about running crons and usage of Cadence UI about crons. So at Uber, about 40% of all usage is in cron and batch processing. There are a lot of scenarios. I just put some common ones: monthly statements. You wait for a month until you have all the data and you need to create statements. This is going to trigger millions of workflows. Let's say you're a company giving your employees Uber vouchers. You issue all of them once, so this is going to be another batch processing. Data or ML pipelines are already by nature batch pipelines. So those are kind of some common usages. So what are the problems with this? So batch doesn't mean that they are all from the same workflow ID. They can be from different workflow IDs. The problem is that the volume is way too high. You can scale your cluster to handle this type of requests, but then batch requests are like, if you're talking about monthly starts, let's say the whole start workflow is going to take 5 to 10 minutes, but then you don't want to keep your whole cluster size that high for the rest of the month. So it is better to distribute that load a little bit. Again, you can use start jitters here that will distribute the start time. And then similarly, as I mentioned, you can do your own orchestration, and some queuing features are coming in the future. One popular question we were getting both internally and externally is that all the cron instances, when they finish, the return result is like continue as new. We want to deprecate this. You want to actually see if your workflow failed or succeeded. And then you want to see if the next workflow is scheduled. So both of those are going to be in the UI soon. Then you will have a much better idea about what happened in your cron workflows and then filter them a lot more easily. Okay, and then this one is in the similar realm. So you will see a couple of things are repeating here, but since it was categorized separately, I will mention this. How am I going to optimize my workflows if I have a heavy load? Heavy load can also mean many things. So it could be too many start workflows. We just talked about this. There are multiple ways to limit this. And then too many signals. This is actually a limitation. This happens very rarely. We don't have an immediate plan to resolve it because of its ROI. There are much higher priority things, but I wanted to let the community know that you can actually DDoS your workflows if you keep sending them signals. It will prevent them closing because each time you receive a signal, we need to see if there needs to be a decision, if there needs to be something new. So you want to make sure if something is sending too many signals to your workflows, you want to make sure you are limiting them. So we already have built-in rate limits. You can use them, or you can use some application logic. But this is something I wanted to add here as a part of heavy load. Key story size, we talked about it. I just put it here if anybody is going to skip to just here, but we already talked about it. For the sake of time, I'm going to skip here. Too many small activities, we briefly talked about it. It can cause hot shards because if you have too many activities from the same workflow that are finishing very quick, let's say within milliseconds, and then you need to run the next one, all of them are going to go to the same shard. So you want to prevent this. Or you can consider using local activities that will prevent going back and forth between the server and the worker. That way you can optimize it a lot better. And then local workflows is something we are thinking. That concept is very similar to having like a workflow where all the activities are local. But we want to kind of control this on the workflow level. More details about this to come maybe mid-2025 or a little bit later than that. Too many timers is another thing, not necessarily again from one workflow. You can have too many timers all triggering at the same time. This can impact timer processing. Today, all the timers are processed under the same queue. In the near future, in early 2025, we want to do domain isolation, domain prioritization, and then different timer types so that if you have a critical scenario, it's not going to be impacted by this. So normally it's kind of like today's behavior is like automatically queuing things for you. But if you have a latency sensitive scenario, you don't want to be queued. You want to execute this as soon as possible. So because of that, we want to have these isolation, prioritization, and different timer typing in the future. And then I think this is the last one under this section, especially with data pipelines. Sometimes the inputs are really big. Sometimes it is like tens of megabytes to gigabytes. The problem with this is that we are using hot storage most of the time, Cassandra. So in any key value store, when your row size is too big, it is going to impact its performance. But as the Cadence team, we want to take as many overheads from you as possible, so you wouldn't even think about this. So internally, again, we built something about this that will automatically upload your parameters to a blob storage or a file storage. and then it will give you an ID, and inside your activity, you will be able to automatically use it. Again, we plan to open source it. It is not open source yet, but even today, if you want to solve this problem, you can do this by yourself in your activity processing. Then you can just pass the blob store IDs between the activities. Okay, worker sizing. We get a lot of questions about this. How many workers do I need? This is really like a hard question to answer because it depends a lot on your workflows. I would say one question in there was saying, should I have many small workers or few big ones? I think there is no significant difference as far as I know. It is just like you can think of like a lambda function execution, and whatever differences you would observe with lambda, it is the same with workers. Memory usage will depend on your total workflow variable size. So whatever variable you are introducing there, it could be some heavy objects like database connection, network connection. It could be some things as small as integer. So think about how much of the memory each workflow is using, multiply it by your sticky cache size. That's how much memory you are going to use from Cadence point of view. And then as long as it fits to your worker, I think you're fine. And if you have big machines, it is underutilized, feel free to increase the sticky cache size. You will be utilizing your memory better. CPU is similar. Cadence library itself doesn't really use significant CPU. Everything, all the CPU uses will come from your workflow code or your activity code. So I mentioned in the previous slides that we will try to parallelize things or increase your worker capacity dynamically. So we will try to increase your CPU utilization as much as possible. We recommend, if we are going to turn on this feature, we also recommend using CPU-based autoscalers. So if your container is going to be fully utilized, you want to keep horizontally scaling. Yeah, this is about this slide. And then I think this is probably the last topic from the user questions. Then we will talk about roadmap. So Cadence team has been a little bit quiet the last 2-3 years. The main reason was that there was an explosive growth internally here. And we needed to handle how to say scalability, reliability, and efficiency. So basically handling all the multi-tenancy and scale problems at low cost. So you would see its impact if you compare managed Cadence prices to similar technologies. All of these are public information, especially at like medium to high scale. Cadence should be a lot cheaper compared to other ones. Where is the biggest source of infra cost? It is coming from database. Whichever cloud provider you go, if you try to get a key value store, you will see that that's the most expensive thing. And that's going to be our main focus. We will either try to reduce the traffic to the database, or we will make it a lot more efficient, either by reducing the size being used or different things. I will explain in the next items. So in the matching service, instead of going to database more often, we try to improve the sync match rate. Sync match is you can think of like an in-memory match. This is partially done. We plan to finish it by the end of this year. Improving shutdowns and restarts and deployments availability is also impacting the cost. This is also partially done, expected to be fully done by the end of this year. Async APIs to handle batch processing for history. This is partially done for start and signal, cron, timers, and child workflows are going to come in next year. Different task queues and prioritization is also coming next year. And sharding remodel, as I mentioned, your workflow ID is a user-given entry. We hope to change our sharding, hopefully based on run ID. That's a Cadence assigned ID that will scale a lot better. I put 2025 here, but that might be a little bit too optimistic, especially if you do well on the other ends. Okay, so database, and we try to use high number of cores to node ratio. Cadence seems to perform better, and overall core usage actually reduces this way. In 2025, we plan to move the closed workflows immediately to a different storage because closed workflows are accessed very rarely. That will save a ton of disk space. And then metadata makes the key value store row size variable. We try to separate metadata from the other history records. That way we can have fixed row sizes for frequently accessed tables, and then others can be in different storage. And then per shard transaction serialization, if there are too many transactions going to the same shard, this can actually create contention. So we plan to reduce this. And on the client side, I talked about local workflows, more details to come about this later next year. And then worker liveness instead of, you can think of like worker heartbeats instead of activity heartbeats. You don't need to write any activity heartbeats anymore once this feature comes. Shared workers is more like, there is also a long tail of domains at Uber, for example, that are very, very tiny, that do very little operation. And even if you use minimum amount of cores, their utilization is very low. So we plan to maybe combine them in a smarter way. This is my last slide, then I will go back to Vinay. So what is coming next year? So we are already redesigning our webpage. We are going to add more tutorials, more code labs, more structured organization. There's going to be runbooks for operating servers, dashboard and alert templates is going to be there. Efficiency, as I mentioned, there's going to be improvements to database and network efficiency. Cadence Web is being rewritten at the moment. A new version is going to be released by the end of this year, and we will add more ops and observability features then. And hopefully in 2025, we will have different user roles. So some users can have read-only access, the others can have admin access. And then we finally started designing how to maintain multiple SDKs in a smart way. And then there's going to be a bunch of modern features coming as I listed here, and then we plan to improve our tooling. I'm wrapping here. Looks like there are some questions. Vinay was letting me know. We can do Q&A, or Vinay, how do you want to proceed? Do you want to do Q&A or?
And then we'll do a Q&A in 5 minutes at the end of the presentation. But for now, we can go to the next one.
Okay.
Cool. So firstly, Ender, thank you so much for sharing the roadmap. I'm sure the audience is as excited about it as I am. Needless to say that we would love to have inputs from all of you to make this roadmap better. So please reach us on TM, reach us on the community channel on the Slack workspace, and let us know what you think. Also, as we mentioned at the starting of the webinar, we'll be covering the topics that we just talked about in much more details in our topical webinars coming up soon. There are also topics that we could not touch upon today. So if you think that there is a topic that is of interest to you, feel free to post it in the hashtag community channel on Slack workspace, and we'll be able to make sure that we have those webinars coming up for you. If we move to the next slide, we know that the community was not much active in the last months, but we are trying very hard to make it better and super active once again. But we cannot do this without all of you, because it's all of us who make this community move forward together. Now, we have the annual Cadence feedback survey live. Please tell us what you think, what your thoughts are, what your ideas are, what suggestions you have for us, because every input would make the community better. Now, every contributor of Cadence is also curious to know what the users want, so please share your views. Over here, you can see what the community activities are that we are planning in the future. Firstly, I understand all of us have a pain of not being able to see the past messages on Slack. So I'm happy to announce that we'll soon be upgrading the Slack workspace that we have. You can expect the upgrade to happen somewhere by October. We are also thinking of having in-person meetups. We are trying to determine which geographical regions all of you come from so that we can organize these meetups and we can meet up in person and discuss about Cadence. Uh, I already covered about topical webinars. We are also thinking of having Cadence Con, which will be a cadence-focused conference, which we'll be planning to do annually. We can expect this Cadence Con conference somewhere in the first half of next year. And last but not the least, we are also onboarding new contributors to Cadence. We have a whole process defined of how we'll be onboarding these contributors. We have a lot of issues coming up, a lot of new ideas coming up, which we'll be working on. And we'll be happy to onboard all of you as contributors to the project. Now let's move forward and let's go to Q&A. I see we actually got a lot of questions today. I see most of them have already been answered, but Inder, do you think there are any questions that you would like to share your views on?
I wasn't able to see any of them while I was sharing. That's why I stopped sharing. Let me take a look. Yeah, Mantas mentioned that there was a community built Python repo, and probably asking like if we can reuse that logic there. We plan to find a way that we can support much more languages in how to say without rewriting the same thing for all the languages. Maybe using a common core as a separate process, but that has some debuggability issues, or we can use some different techniques to be able to generate code for other languages. So those are being actively brainstormed at the moment. We will see more, but probably for API implementations and for language idioms, we will look at those community build repos previously. I think we have JavaScript, Python, C Sharp. I don't know if it has C++, but we need to check those to see what users actually thought about them. And then I think, okay, so we have about 10 minutes. I need to read them to understand. Maybe I can start from the short ones. So Asaf asked, any interface we can extend. Oh, yeah, this is actually, I don't know if, I think you're approaching this from a different angle, but I wanted to mention that this is a very common, so there's a very common problem I might want to share. So Cadence is more like a programming language in distributed systems that you can build anything. And there is a lot of, how to say, specialized workflow engines. Think of like Airflow, Conductor, and the list goes on. What you really want to have is to have a strong backend engine supporting those interfaces. And with a backend engine like Cadence, it's actually a lot easier to implement those interfaces. So we actually plan to do something like this, but I think it's going to be maybe next year, maybe towards the end of it a little bit. And then, yeah, PubSub, I'm wondering if this is referring to getting, whenever there's an update in workflows, you want to be notified. We had a project about this. We didn't have a chance to start yet, but if it is this, I think we might need to prioritize based on how important this is. Okay. Any plans to decouple advanced visibility from Kafka? So there is actually a good change in, since we are using Cassandra at Uber. Cassandra recently released vector search. So we are on V5 currently, version 5. And if it actually works, we might be able to drop both Kafka and Elasticsearch, OpenSearch, or Pinot, whichever you are using, and directly use Cassandra. But we did not explore this at all. But I see the concern. You don't want to maintain multiple technologies in your company, especially if the company is not that big. Not specifically talking about your case, but I hear that from smaller companies, this is a bigger problem. So we do plan to reduce the number of different technologies. So hopefully it's going to be a lot smaller number of technologies in the future. Then somebody asked, Shams asked, I would love to see optimized way of Cadence deployment in production environment that's also in highly available mode. So one thing we did about deployment last year, so if you are in the community for a while, our releases were a lot less frequent. Now it is more like every 2 weeks. We do get this question about how can we have like a upgrade engine. So maybe one thing that can help is that we are about to release our Helm charts. So hopefully that will help a little bit. But I did see some automatic deployment engines. That's going to be a little bit tricky to prioritize at Uber because we have our own deployment engine. But I did see some technologies like it would be really cool to see new version available on Cadence Web and then click a button saying upgrade and it will upgrade your whole cluster. That I don't know if we will be able to prioritize, but if anybody wants to help in the community, maybe we can work together on this one. I do recognize the problem there.
I see a question from Asaf. Is there a guide someplace that covers JSON Web Token authentication? Will it be able to post something?
I can't see the question, but
Go to the open questions, and there you might see it over there.
okay, it's open now. The
Yeah.
guidance. I would ask this in the workplace. I might be able to get it answered by one of our engineers. We do have authentication support. I don't know if we are supporting JW. I think we do, but I need to get answer from engineers about this. And then he said this will force us move to Cassandra. I mean, visibility is like you need to use a column-based or column-based database or some sort of search engine. So we are using Elasticsearch because it is a search engine, or we would use like a vector search because it's a column-based engine. I don't know, like if you can do it with regular key value stores. I think the domain is very narrow, supporting both scenarios. I don't even know if Cassandra v5 is going to work there. So you might have to decide there. We do support visibility on regular Cassandra, MySQL, and Postgre too, but since those databases are not optimized for this, those are a little bit slower. But maybe in your scale, that might be okay. Feel free to explore those too, because all of our visibility plugins are also implemented in those engines.
Cool. I think, Ender, we have covered all the questions now.
Okay.
We are good. Cool. So this brings us to the end of the webinar. Thank you so much, everyone, for joining. Thank you, Ender, for taking us through all the topics that you had. I know it was a lot.
Thank
But
you
I
for
hope
organizing.
I hope everyone is going away with a lot of insights, and we hope this session was helpful for everyone. If you like the webinar, feel free to give us a shout out on the community channel, and we will keep announcing more webinars in the future on the announcement channels for the Slack workspace. Thanks so much, everyone, and all of you have a good day.